right, so welcome back. This is going to be part 2 of section 6.1. We are looking at calculating probabilities, and we are going to be using technology to do them. All right, so let's go ahead and get started. Remember, please don't use tables. They aren't going to help you. They're not going to make you understand this more. All they're going to do is frustrate you. So let's take a look at how the problems are going to be delivered, and then how we use technology to find them. All right, so here's our first problem. We're supposed to find the area. Oops, I thought I had a highlighter. Find the area of the indicated region under the standard normal curve. Now, as soon as I see that phrase right there, I know that I'm working with a curve that has a mean of 0, a standard deviation of 1, and it's a normal curve. It looks like I'm looking at a left tail problem. And since this is a left tail problem, there is no stated lower limit, but there is a stated upper limit. All right, so now I'm going to go to the calculator. All right, I'm going to go to my distribution menu, and I'm going to find that normal CDF, the normal cumulative density function, which finds area under a normal curve. It's going to ask me for a lower limit. As I stated a moment ago, no lower limit was given in the problem. Since there is no lower limit, we choose a large negative number. I've got negative 10,000 there. That seems good enough for me. Now I'm going to put in the upper limit. Looks like the upper limit is negative 1.30. Then I'm going to put in, mean is 0, standard deviation is 1. Those are already good. I'll paste that back in. I'll calculate it out, and I get that the area of that region, okay, so the area of that region that we just found, is, what is that going to be? Almost always they're going to ask for it to 4 decimal places. 0.0968. Right? So now, how do we interpret this? What does this mean? Well, if they were just asking for area, we would say the area is 0.0968. If this was a probability problem, we would say that the probability that z is less than or equal to negative 1.30 is 0.0968. I want to point out a couple things. Why did I use z here? I use z here because I'm dealing with a standard normal curve. Standard normal curve, it's always z. Right? And then I wrote my inequality to represent that left tail. That negative 1.30 is an upper limit. Okay. All right, moving to the second problem. Now, when I look at the second problem, I can treat this problem one of 2 ways. Hopefully, you're noticing, 1, standard normal again. So that means that we've got a mean of 0 still, a standard deviation of 1. But is this problem the complement of the one we just did? So I could solve this problem by saying that the area for this problem is just going to be 1 minus 0.0968. Because the way that these curves work, if the area under the whole thing is 1, and I know that the left tail is 0.0968, then the right tail better be 0.9, what is that going to be? 0.032? But let's say I didn't catch that. Let's say that I wanted to use technology to find this. All right, so I grab my calculator. I'm going to go back to my distribution menu. I'm going to grab that normal CDF command. But now this is now going to be my lower limit. And what's my upper limit? Well, since I don't have a stated upper limit, I'm just going to use a big number. Mean is still 0, standard deviation is still 1. Paste that back in, and 0.9032. So I could say that the probability that z is greater than or equal to negative 1.30 is 0.9032, rounded to 4 decimal places. Right? All right. The third type of problem, since we've done a left tail and we've done a right tail, the third type of problem is this one, where we have a strip in the middle. Okay? Still a standard normal curve. So we still have a mean of 0 and a standard deviation of 1. But now we've got both a lower limit and an upper limit stated. So when I take this over to the calculator and I go to my distributions and grab that normal CDF command, I have both a lower and an upper stated. So I can type those in. Mean is still 0, standard deviation is still 1. And I get then that the probability, or the area, from negative 0.45 being less than or equal to z to being less than or equal to 2.11 is 0.6562. Okay. All right. Those right there are the three basic problems that we'll see again and again and again and again. A left tail, a right tail, and a strip in the middle. A left tail, a right tail, and a strip in the middle. Now, the one modification is sometimes we'll see this problem. Now, when I'm looking at this, there are two ways that I can treat this problem. One, I could find the left tail, I could find the right tail and just add those two pieces together. Or two, I could treat it like a complement problem, find the pink, find the strip in the middle, and subtract from 1. Okay? Now, I'm lazy, and I want to do the least amount of work possible, so I'm going to do it as a strip in the middle. And I'm going to find the area of that pink piece, which has a lower of negative 1.13 and an upper of 2.03 at 0.8496. And then I'm going to take 1 minus that 0.8496 and get that our actual area of our two regions is so 1 minus 0.8496 is 0.1504. Right? So the area of those two tails, that left tail and that right tail, is 0.1504. Now, the hard part is writing it. To write this, I would have to say the probability that z is less than or equal to negative 1.13, which is going to give me that left tail, or z is greater than or equal to 2.03, which is going to give me that right tail, is 0.1504. Okay. This is our left tail as math, as an interval. This is our right tail as math, as an interval. And then we write those two things. We link them together with the or because we want at least one of them to be true. All right, so I'm going to zoom out a little bit here and say that these four right here are basically it. All right. Now, these are also the nicest versions of these problems because someone has drawn the picture for us, making it very obvious whether it's a left or a right or a strip in the middle. As soon as they start just writing the problems in words, then things get more complicated. So let's take a look at just a strictly word problem, see if we can make sense. Find the cumulative area that corresponds to a z-score of 1.15. Okay. The fact that we're looking at a z-score tells me I'm dealing with a standard normal distribution where my mean is going to be 0 and my standard deviation is going to be 1. So I know that the middle of this thing is 0. So this positive 1.15 is over here somewhere to the right. So 1.15. Okay. What does this mean? Well, cumulative area is the fancy way of saying start at negative infinity, technically, and accumulate area until you get to the stopping point of 1.15. So in terms of the probability statement, we want the probability that z is less than or equal to 1.15, a left tail problem. And once I figure out what type of problem it is, then it's just a matter of grabbing the calculator, going to the normal CDF command. There's no lower limit given, so that negative big number again. Upper limit of 1.15, mean of 0, standard deviation 1, paste it back in, 8749. Whoops, I didn't want that. I wanted that. 0.8749. All right. Now, when you take a look at this next problem, is the next problem the same thing? Well, it says find cumulative area, so that means I'm looking at a left tail. Z-score, standard normal distribution, all they've done is they've changed it from a positive Z-score to a negative Z-score. So I think this is essentially the same problem, just we're over here now. And they want this left tail. Z-score tells me that my mean is still 0 and my standard deviation is still 1. I got that from there. So yeah, this is just the same problem again. So back to the same distribution. Only thing that's changing is now I'm looking at a negative 0.24 for my upper limit. And I get 4052. So the probability that z is less than or equal to negative 0.24 is going to be 0.4052, rounded to 4 decimal places. All right? So here's the big takeaway. What does that mean? Cumulative area means you're looking at a left tail problem. Okay. All right, let's read what this one says. Find the area under the standard normal curve right there. So that's good. So I know that I'm looking at a standard normal distribution. My mean is going to be 0. My standard deviation is going to be 1. And they want the area to the left of z equals negative 0.99. So negative number is left of middle. And they want the area to the left. So this is just another left tail problem. I can do that. I'm getting good at these. So I grab my calculator, go to my distribution menu, normal CDF, no lower limit given, so I use that negative big number. My upper limit is negative 0.99. I paste, and I get a 0.1611. So then the probability that z is less than or equal to negative 0.99 is 0.1611. Okay. These aren't too bad. Okay. All right. Find the area under the standard normal curve to the right. Okay. So a right tail problem. So standard normal curve, mean is 0, standard deviation is 1. My z-score is 1.06, so that's somewhere over here to the right. And they want the area under the curve to the right of that. They want that piece. So it's a right tail problem this time. That's okay. I know how to do those too. I'm going to my normal CDF command. Now I have a lower limit. That's 1.06. But what I don't have is an upper limit. So I'll use some large number. 10,000 sounds good. Paste it back in. And I get 0.14. So then to write it up and make it look pretty, I say the probability that z is greater than or equal to 1.06 is 0.144. Would that be 1446? 1446. So left tails, right tails, no worries, I can do these. All right, what are they asking here? Find the area under the curve between. Oh, okay, between. So this is going to be a strip in the middle problem. So again, I'm looking at z-scores, so I know I'm dealing with a standard normal curve where mean is 0, standard deviation is 1, from negative 1.5 to 1.25, and they want that in the middle. So they want the probability that negative 1.5 is less than or equal to z is less than or equal to 1.25. So back to my distribution, normal CDF again, lower limit of negative 1.5, upper limit of 1.25, mean 0, standard deviation 1, paste it back in, 0.8275. Yeah, perfect. Okay, so some notes about this. These z-scores. Z-scores are values on that horizontal axis. They are a distance, if you will. They measure a random variable. The area is the region bounded by the z-scores and the curve above. Okay, so just keep that in mind. The thing you want to keep in mind here is that what we're working with is finding areas, interpreting areas as probabilities, and then making statements about the probability of something. Now, all of these examples are very generic. They have no meaning. So let's look at one that has some meaning and see if we can wrap our brains around it. Okay? All right, so here's our first example. We have some meaning wrapped around it. The U.S. Navy requires that fighter pilots have a height between 62 and 78 inches. Okay. Can't be too short, can't be too tall. I guess maybe you wouldn't fit in the cockpit of the fighter plane. I don't know. I'm not a pilot, but okay. Given that men's heights are normally distributed, okay, so men's heights are normally distributed with a mean and a standard deviation of those two numbers, and women's heights are normally distributed with a mean of this and a standard deviation of that, what percent of men and of women would not be allowed to become Navy fighter pilots based on height alone? Okay. So it looks to me like this is actually two problems in one. One where we're going to do the work for the men and one where we'll do the work for the women. And we got to figure those out. All right, so since men were stated first in the problem, I'll do them first. So I'll split my page in two. Over here, this is going to be men's. And we're told that it's normally distributed, but something changed here. This is not a standard normal distribution. This is a normal distribution where our mean and our standard deviation are now real numbers, 68.6 inches and 2.8 inches. It's not just that generic 0 and 1. Okay? So 62 for a lower limit is going to be somewhere over here. 78 for an upper limit is going to be somewhere over here. Okay? This that I'm shading here in yellow, that's going to be all the people who can become fighter pilots. And this is the people that are too short or too tall to become fighter pilots. So we need to find the pink area. But I'm going to treat this problem like I treated that one earlier, where actually what I'm going to do is I'm going to find the yellow area and then subtract from 1 to find that pink area. So let's see, I'm going to bring up my calculator, and I'm going to say, okay, go to my distributions, grab that normal CDF. My lower limit is 62. My upper limit is 78, but now I've got a mean of 68.6. So I'm going to change that. A standard deviation of 2.8, change that, paste that back in, and I get 9904. So 0.9904 is the yellow area. So 1 minus 0.9904 gives me 0.0094, or less than 1% of the men would not meet those requirements. Okay. Now my pen stopped working, so I'm going to stop this video here. We're at 18 minutes, and I'm going to restart my system and come back and finish the other part of this problem there. Okay. All right, see you back here for part 3.